Hello and welcome to A-Level Computer Science. This is meant to give an introduction to what the A-Level is about. And last year we created a video, just a 2-minute introduction that had the main points of the A-Level. So I'm going to start off by playing that, and then I'll go through in more detail about what the A-Level takes.
Welcome to Computer Science A-Level at Shenley Brook End School. The subject is about how computers work and what goes on inside and how to program them. Computer science is not about using pre-written programs such as spreadsheets and databases, but how to code your own programs considering all aspects of input, process and output. There are lots of different input devices and we consider how these work. We consider what is the process. Is it a computer? And if so, what type of computer? Or is it a single purpose program within a processor? And ask, is that a computer? Then we look at what is required as output and how that happens. The process is controlled by a program, and we look at a range of languages, using Pascal as a high-level language to write programs. This language gives an excellent understanding of how to program from first principles and is a good preparation for the code used in the exams. It is used for the A-Level coursework that contributes 20% to the overall final grade. There is no need to have studied the subject at GCSE since we assume no previous knowledge. Computer Science A-Level is highly regarded by all universities, especially with an understanding of programming using Pascal, and in Shenley Brook End Sixth Form it is taught by subject specialists, including a former chief examiner. I hope that this has inspired you to find out more about the A-Level.
So that was a very brief introduction, and what I'm going to do now is take a little bit of time to talk through each of those aspects and to tell you about why computer science is a fantastic A-Level to do, and also why it's good to do at Shenley Brook End School. So I'm hoping that you can all see the screen. If you do have any comments as we go through that you want to put into the chat box, please do that, and I'll try to address them as I go through the presentation, and there'll be an opportunity at the end to ask any questions. So the example that we do is OCR, and so you can always look at the specification online to do that. We like the OCR specification because it has a good programming project, which is worth 20%, and it allows you really to learn a programming language in a lot of detail, but in your own time. And so that coursework is carried out throughout the 2 years of the A-Level. It's submitted either near the end of year 12 or into year 13. But that's 20% of the whole A-Level marks, which is a really good start to go into the exam with. And then there were 2.5-hour exams. There's a very brief slide that if you wanted to come back to the recording to have a look at to see what the contents are, it covers all of the areas of computer science, looking at the theory behind it. One thing I want to make clear is that it is not IT. It is not about using other people's software. It's about creating your own software and then understanding how programs are actually executed when you're using a computer. So it's not about using the computer, it's about understanding it and controlling it yourself. So if you've done any IT or computer science before, you will understand those three letters. If you haven't, don't worry, I'm going to say what they mean in a moment. But IPO is about understanding what goes on about a computer system. So that stands for input, process, and output. And we relate everything we do in computer science around those three areas. But on its own, that's not enough, because you have to have an understanding of what happens before input, because you can't input something until you've actually got the thing or things that you are going to input. And so that is about data capture. So when we look at the use of computer systems, you have to understand how they're used in real life. And in real life, a systems analyst will look at what is it that your client, that the user needs, what data are required to enter into the system. And this is what's actually carried out in your coursework, because at Shenley Brook End, we expect you to have a real client, to find out what they do, and then you write a computer solution, a program to help them. And all of our students at Shenley Brook End School, it's usually a relative or a neighbour or a teacher who will be your client, but they will give you that real life aspect. And that's why data capture, you have to think about how do you get the data to the computer system, and then how do you input it, and what is it that you input. Then the process is the program that is used to manipulate that data, and then you get some output. Now, the output depends on what the user actually wants. And again, in your coursework, you have to find out what information is it that the user needs. And in a real life situation, that is not just, for example, using a computer game. And games are very rarely mentioned in the computer science A level. So if you think that you're coming into the A level to use computers or to look at games, that's not the purpose of the computer science A level. It's looking at what happens when the computer program is actually being executed and how it's executed, not just using other people's work. And of course, games and graphical interfaces, all of those are other people's work that you're using. And that's not what the A level is about. So we look at situations where output is used by other people. For example, in the summer task that's going to be set is looking at how a doctor's surgery might use some output. And with that output, you have a human element, because what happens to that output? Well, a person will use that output and then will apply their knowledge to that output to make a decision on what to do with it. So that's used in lots of situations. So, for example, a diagnostic computer program for a car in a garage. The output will give the situation of an engine, and then a mechanic will apply his or her knowledge to that output and then make a decision on what's the best thing, how to mend that car, how to improve it. So actually the IPO is only part of a bigger system involving people. So what do we need to know about data? Because a lot of students get confused between the data itself and the device that it's entered into the computer system with. But the first thing you have to look at in computer science, as a systems analyst, for example, is, hang on, we're not going to look at how we're going to enter the data until we've identified what the data actually is, what data are needed for a system. And that's the first thing that you have to identify with your client in a real life situation. So when you know what data are needed, then you can look, first of all, at how do you collect it? How does it arrive at the computer system? Don't immediately think of how's it going to get into the computer system. You've actually got to think how it's going to get to the computer system itself. Then you can think about what the best method is to input the data. and only then can you look at the devices that are needed. And there's lots of factors that you then take into account when you're looking at those methods. Is it speed? Is it cost? And I'll look at a couple of examples during this presentation to show you the idea about how computer scientists, systems analysts think about a system before it can actually be implemented. So we'll look at a supermarket at the checkout, for example. So what I want you quickly to do is, in the chat box, just to make sure that you're there and listening, is at the checkout, at the system where it's going to be putting the product at the checkout, what computer system is being used? But I want to ask the question, what data is needed to enter into the computer system at the checkout about a product? So you've got a product at the checkout, you're going to buy it, the checkout artiste is going to enter it into the computer system. I'll give you a clue, perhaps by a scanner. What is the data that's needed? Put it into the chat box now. We have a couple of brave people putting comments in. Going to be a bit mean, put something on the screen now. Barcode is not correct. We have a correct answer in the chat box. Some interesting data going in, so that's very good. Thank you for that. So I was expecting one answer, but in fact there are a couple of correct answers there, but they come in from different situations. So at a supermarket checkout, the main thing, if you put barcode, the barcode is a method of entering data. It is not the data itself. And so therefore, the data it actually needs about a product is its ID, its identification. It could be a product ID, as somebody has put into the chat box. Well done. And so that's got to be entered into the system. Now, there are various ways to enter the product ID into the system. One is by representing it as a barcode, but that's not the only way. So, for example, if a barcode is not read because it's dirty, then the checkout artiste can enter it using a keypad and type in the number. So it's the ID that's being entered, and there you've got two methods of entering it. Now, other people have put into the chat box a number of items. So if you're buying, for example, 5 or 6 or more of a particular product, it might be quicker to enter the ID once and the number separately using a keypad of that item. Excellent, that's also correct. Price is interesting because, yes, price has got to be entered into the system, but it's not actually from the product itself. That is already stored within the system, and then the process will have to search for that price and input it from backing store. So that's good. Weight could also be there if you're buying fruit and veg, and we'll move on to that because, in fact, the next slide shows a system of using fruit and veg in a supermarket, and this gives an idea about how we think about the system. Now, in IT, we would just use that system and accept what it's doing. In computer science, what we're looking at is how does it work? What are the input and output devices there? What's the processor there? Is there a processor there? So when we look at that, this is where you have screen or keys with pictures on it. So it could be a screen showing pictures. It's more likely to be keypad with pictures on it, which is called a concept keyboard. Now, is that input, output, or input? Just input. If it's a keyboard or a keypad, then they are just input. And a keypad like that is a pressure sensor. So dependent on which key you press, you actually create a pressure behind it, and therefore that particular key is recognized as an input device by the program it's running. Then you can have a mini monitor, which is a screen showing the weight and the price of what you're weighing. So that is an output device. If you look carefully, there's a mini printer there which will print a label to stick the produce with a barcode, but that barcode will include the price, unlike the barcode on, say, a tin of beans, which will only have the product ID. This, because it's printed in the supermarket and not by the manufacturer of the beans, would actually be able to print the barcode, which can include a price, which speeds up the time at the checkout. So therefore, that method is chosen because of speed. It's also quite a cheap method to use, printing a barcode. And those are some of the things that you have to think about when devising a computer system. Then you have scales. Now, these can be connected to a pressure sensor to weigh what is on that surface. So that's another input device that goes into the processor that's taking in all of these inputs in order to then process them by a program that has been written by a computer programmer, and that will control what output is from there. And then there's tomatoes, or are they? Because actually, what determines whether they are tomatoes or not? We can look at them and say they are tomatoes, but a computer system can't look at something. It hasn't got human attributes. And so therefore, the only way that this particular system recognizes that it's tomatoes on there is by whichever button the user presses. So if the user had pressed another button, say for example they pressed potatoes, then that would then be input as a code for potatoes, and a different price would be generated. And these are the kind of things that we have to look at, because clearly if people use this system and push the input button of a cheaper fruit or vegetable, then the supermarket will be losing money. And it's about that balance between convenience and cost, and indeed honesty. So, for example, there is one case a few years ago where somebody went into a large supermarket, and they were selling goods as well, electrical goods, and somebody got a DAB radio, took it to the fruit and veg scales, put it on the scales, pressed potatoes, and then printed the barcode out and put that barcode over the barcode of the DAB. So when it was scanned, it was actually scanned as potatoes at a much cheaper price than the radio. And so what we'll do is that comes into computer ethics as well. Interestingly, that person got away with it, and they walked out with the radio having only paid potatoes for it. How people then knew that it happened, they thought that was a good idea, went in the next day, did the same again, but this time got caught. Never cheat. That's the moral of the story. And then there's a question there, what's this? Well, we don't know, because we haven't devised the system. It might just be a cover to the on-off switch, or it might be a laptop that is connected to that particular system where you can program the prices. And we would only know that if we were part of designing the system. So on there is a snapshot of a similar type of system. So what I want you to do is, in the chat box, I'm going to say a letter. Hopefully you can see the letters clearly. And all I want you to do is type in I if you think it's input, O if you think it's output, P if you think it's process, or IO if you think it's input and output. So I'm going to say, first of all, what is D? Top right hand corner, what is D? Type in I, O, P or IO. Excellent. I'm not catching it out. You're all putting O. It's an output device. So therefore that is output. And you can see an example of what might be output underneath it. Printed onto that paper are carrots and then the price with some weight there. What do you think B is? So the middle on the left, B. I, O, P or I, O? Yep, that's another output device. Well done. It's a mini monitor, little screen that can do that. What about E? Is E, now listen carefully to this, I want you to put what device is E? Is it an input device, an output device, a process device, or an IO device? E, in the middle at the bottom. Is it an input device, an output device, a process device, or an IO device? The responses are a bit slow here because it's a trick question. It's nothing, it's neither, it's none of them. It's not a device at all. It's used for an input device, but itself is just a medium. It's just a method. So that is a barcode. So it will be used as an input device, but it is not the device itself. And this is where we start making the distinctions quite clearly. The actual device that will be used with that will be a laser scanner or a handheld optical scanner, but itself, it is not. And in fact, on that particular one, going back to what I was talking about at the beginning, the ID itself for that, that's the thing that's being input. So the number at the bottom, 12000 00230, with the 0 and the 4 either side, that is actually what is being entered. So it could be used by a keypad as well. It doesn't have to be used by a barcode scanner. And another trick question I was going to ask, what is F? And clearly it's an apple to us, but the computer wouldn't know that unless the Apple button was pressed. So therefore I was going to do that. Got a question coming through on the chat room. What exam board will we be using? It's OCR. So I'll give you more details about the books that we're going to use at the end as well, but it's an OCR exam board. So we look at other input devices here as well and output devices. So looking at something like a greenhouse, that can be, well, is it computer controlled? A lot of people say things are computer controlled, and in computer science, we don't like that. We like to be more precise. So the inputs for such a greenhouse system like this would be the temperature, would be the humidity, and that's the data that needs to be input. Now, output, look on the right hand side, it's talking about heating and watering. So a simple Y or N for yes or no in the chat box. Does this mean that heating and watering are outputs of that particular system? Put it in the chat box now, either yes, heating and watering are outputs, or no, heating and watering are not outputs. Quickly put something into the chat box. A few brave people putting in an answer, and the answer I like best is yes with a question mark, because clearly heating and watering are going to change. But what you have to think about in computer science is not what the effect is, but when you think about output is what is the output from the computer system. And a computer system can't produce water. So water can't be output. What can be output is a control signal to turn a watering device on or off, or increase the flow or decrease the flow. Likewise, a computer system won't produce the heat for a greenhouse. Now, ironically, computer systems do produce heat, and a lot of technology goes into reducing the heat that a computer system generates, but that's not the heat for the greenhouse. That will be actual heaters controlled by a signal that is output that will either turn the heating element up or down, on or off. So again, in computer science, what you have to recognize is the difference between the effect and the devices that you need, and what actually is the input signal data, what is the output signal or data. And this is the kind of thing that we look at in detail. And so if that's not the level of detail that you're interested in, that then computer science is not the right subject. Probably IT is more the subject if you're just looking at the effect of the output, because in computer science we look at how that happens, not what the effect is. I'll give you an example. In a cash point machine at a bank, it has got processor control in there, and people think that the output from the processor system is money, because that's what you get out of a cash point machine. But again, a computer can't generate money, or at least if you do find one that does, tell me, because I'd like one of those. That's why you don't just do the immediate thing, oh, money's output, therefore that's the output from the computer system. It can't be. Think about what you're talking about. So is temperature the data or a device? Well, temperature is what's occurring naturally outside. That's data, and that's the data that we need. And so a systems analyst, a computer scientist, will then make a decision, how do we get that data into the system? And on that little video at the very beginning, there were something called sensors, input devices called sensors, which have been manufactured to actually convert the outside temperature into a format that can then be converted into a computer format. And that's the role of an input device, to convert the data that you want to get into the system into something that can then be used by a program. So that answers the question as well. Well, I've just put on the screen, is water the output? No, of course it's not, but the control signal can be. So this is the slide that I was talking about. There are a whole range of input devices that They've got different types of sensors, cameras, other types of input devices. And you can come back and look at that, because part of the summer task will be for you to identify as many different input devices, as many different output devices, and as many different processors that you can. So I want you to think about that, and then with those letters A, B, C, D, E, F, are they all only output devices? And I'm going to tell you the answer now, because we're getting nearer to the end of the lesson. I want to finish off with all the information. They're not. F, if you look at the bottom right, is not just headphones. It's also got a microphone in. So the microphone is an input device, and the earphones are just speakers. They're an output device. And E might not only be a printer, it might also be a scanner. And so therefore that might have an input section to it. So there'd be an input device and an output device wrapped up together in one packaging. Now, I said in the video at the beginning that we use Pascal as a programming language. It's not a modern language. It was developed actually well before all of you were born, but it was designed to teach computer science to university students. So it's an excellent programming language to learn what called data structures. It's about really understanding what goes on inside the computer. So we use that in our teaching because it's the best way to teach computer science. Yep, it doesn't give flashy output and graphical displays, but then again, any programmer that uses such a program is not programming that element. They have been programmed for you to use. So actually it's more like IT. It's using somebody else's work and not your own. When you write a program at Shenley Brook End for your computer science coursework, you will have written every single line and have crafted every single program, which is why the coursework marks at the school are usually excellent. We get a lot of students who get 100% in their coursework because they have crafted those programs. And we've even had students getting a lower offer at top universities like Warwick because they have learned to program in a way where they've had to really understand computer science. So that's why we do it. And it also really helps with the exam, because in the exam, they will be putting what are called algorithms for you to understand, and the format of those algorithms of what's called pseudocode is very, very similar to Pascal. So you don't have to learn another language to understand the exams. We start doing that right from the very beginning. And in fact, what's on the screen at the moment is the very first program that you'll write in Pascal. However, look what I put on the right hand side. I've called it a computer program in quotes, because that's not a program. A computer program is something that the processor requires to control it. That won't control the processor, because that computer program is written in a language, a high level language that we as humans understand, not what the computer understands. And so having written that program, it has then got to be converted into a format that the processor can understand. And we talk you all through that. So that's the computer science. So we call it a programming language, that's fine, but that's what's called source code. It's not the program itself. So it's got to be converted. And that's the level that we go to in computer science. So then what is a computer? What is a processor? So on the screen there are things that a lot of people call computers. Now the top left is a desktop computer, bottom left is a laptop, top middle is a supercomputer used in things like weather forecasting. But then a lot of people look at the bottom middle and say, oh look, a sat-nav system in the car, yep, that's a computer system. Oh look, top right is a fridge. And people say, yep, there's a computer. You get computers everywhere nowadays, even in fridges. Well, that's actually not right. They're not computers. They might have been developed using computers, but when they have finished, they are then put into a processor. And that is different. If you really want to see a computer in a fridge, then There's one. That is a computer in the fridge. It's not a processor. Then we talk about computer programs. What is a computer program? Well, everything inside the computer is in binary. And so the program that is written in Pascal, or even in a lower level language called assembly code, has got to be converted into a program. So that could well be a program inside the memory, be represented by zeros and ones. There's some examples of different outputs that you can get. Formatted for a printer, so signals will be sent to a printer or a plotter in order to produce output. A lot of output from computer systems is printed or put onto the screen. Either of those are the most common output devices. But there are other output devices. So for example, if you look at that, there's what's called a cochlear implant to help deaf people hear, and so signals are then sent directly through to the nervous system. Bottom left is a robotic arm, and there are output signals from the computer that are sent to motors to operate it. Top right, a self-driving car. What are the output signals there? Bottom right, behind the virtual reality goggles, is output to a device for blind people to be able to read Braille. So we can look at all of those devices and how they work. It's understanding the theory behind them, obviously not using them all. And so therefore, we're coming to what is inside the computer. Well, everything is in binary, as I said. So a lot of people just say, oh, what's a machine code program? And they just say, it's binary. Well, that's not a good answer. It's not a computer science answer, because everything inside the computer is in binary. So therefore, in fact, we find out that it can only be one of 4 or 5 things. So when you see binary as a computer scientist, it'll be one of those 4 things. It'll be a number, a character, a Boolean, or a machine code instruction. But in fact, number is divided into 2. It can either be integer, a whole number, or real with maybe a decimal part. And we look at how all of these 4 things are coded inside the computer and how to interpret binary. That's the level that we go to in computer science. So what about colour, sound, animation, robot movement? If I say that those are the only things that they can be, well, we find out in computer science how they are represented. And in fact, all of those things, colour, sound, animation, robotic movement, etc., are all numbers, characters, or Booleans. So programming language, I mentioned Pascal is used. Why? Because it's a fantastic teaching language. It uses a structure that is very similar to the coding used by the exam board. All of the actions of the computer are controlled by a program. A program must be in machine code for the computer to execute it. A Pascal program has to be converted to machine code for it to be used, and we'll look at all the stages. You have to know that for the exam. So the Pascal program is called the source code, and the machine code is the object code. And that's the first program that you'll look at, and I'll explain how to lay out a program, how to design it, and that all leads towards your coursework. So the first program will have 3 elements of it: to get the 2 numbers to add, then they're added, and then they're displayed, which actually fits in nicely with that idea of input, process, and output. But you will also learn the theory behind other programming. So assembly code, for example, which is a low-level language, and you will write simple programs and have to understand simple programs in assembly code, and the OCR exam board uses the Little Man computer instruction set. That's all taught by the computer specialists that you'll have teaching you. We'll also look at the theory and some example statements of structured query language. So SQL, looking at how to interrogate a database by using commands. So you have to understand that. You also have to understand HTML and CSS scripting languages. So the hypertext markup language, you have to understand how some of the instructions work in order to be able to answer questions, and also how to change the style sheets, the Cascadian style, in order to change the appearance of particular HTML code. And that gives you an example of how the same data in HTML can be represented differently by using CSS instructions. So that's all the content of the computer science. We use the OCR A-Level Computer Science textbook. If you do study the subject, you will need to get this book, the one on the left. It's not the best A-Level textbook, but it is for the examples that we do, because it's written by the Chief Examiner, and so therefore it's in the language that the Chief Examiner will use for the exam. So what that means is that's the introduction to A-Level Computer Science. I hope that you found it interesting in terms of explaining the content. So if it's not the content that you want, it's not the right subject for you. But if it is the content that you want, then that's the A-Level subject to you. So if you've got any questions, put them into the chat box now, and I'll try and answer them before we finish. So there is a question: will there be the option of using a programming language other than Pascal in the coursework? The answer at Shenley Brook End, unfortunately, is no. We get this question each year. It's a very popular A-Level subject, and so therefore the group sizes are bigger than most other schools. And so we haven't got the time or the facilities to supervise coursework in other programming languages. Plus the fact that Pascal, as I've said before, is a very good teaching language. It will prepare you better than any other programming language for the exam board. So therefore, if the programming language is really, really important to you, I do suggest that you do look at other schools that allow different programming languages. The problem with other programming languages, they look prettier, the results, I'll give you that, but you don't get the credit for them because you haven't programmed those instructions yourself. And that's what universities recognise about Shenley Brook End School, that they've been taught proper computer science and understand everything they've programmed, not just use other libraries or routines from other programming languages. So that's why we use Pascal, and that's why everybody uses it, because I think it's a popular subject at the school because the results are usually outstanding. We get a lot of A stars and A's at Shenley Brook End School because we focus on the computer science about it. There's no Raspberry Pi programming. A question in the chat box says, is there any programming associated with Raspberry Pi? Not at A-Level. Raspberry Pi is a good introduction level to lower years. At sixth form, we focus on the computer science of it, and therefore we look at how processors and how programs work, but we only use the programming languages that I've mentioned on there. So Pascal, Little Man Computing, HTML, CSS, and all of that is focused towards the exam as well. So not only do you get a good grounding in computer science, but you also get it directly related to the exam, which is why students again do well. In the past, we've had students in the top 10 in the country getting an award because with computer science specialist teachers, we're able to focus on the content and the exam. And I've been the chief examiner of computer science for an exam board in the past, so not only able to teach the content, but also guide you how to get the best in an A-level exam situation. And that's why I think not only is it a popular subject, but it's also very successful. Hopefully that's given an introduction. I'll just wait a minute for any other questions to come through on the chat box. If you do have any questions, then you can put them into the sixth form team, and either I or Mrs. Elliott, who teaches the subject, will be able to get back to you. Otherwise, I hope that you found this a useful introduction, a taster to Computer Science A-Level at Shenley Brook End School. Thanks everybody, and goodbye.